Okay, guys, so a very good morning to all of you. This is once again, I welcome you all in this lecture, which is based on the fundamentals of manufacturing processes. So, in the first lecture, last week, we started this subject and we started with the very basic, that is, what is the content part that we have to discuss in. That we are going to discuss in the fundamentals of manufacturing processes and like all the 5 units that we have discussed, so that is related with the introduction part of the manufacturing technology and casting, welding, machining processes and the additive manufacturing. Okay, so that we have discussed, and in the last lecture itself we started the first unit. So from the first unit, like, there are three concepts basically. First is that which is based on that why we are going to study the manufacturing technology or manufacturing processes. So that depends on the term which is men's material welfare, MMW. Okay, so that we have discussed. So there are three types of the things that we considered for that. That is, first one is the natural resources. Okay, then second is the human efforts, and then it's tools. Tools means what are the plants that we have formed. Okay, by using the different natural resources along with the human efforts. Okay, so that we have discussed, and we derived one of the formula, and we discussed one of the standard definition for the MMW, so that we have gone through, so that we discussed in the MMW. And secondly, we discussed about the different types of the manufacturing processes. Okay, so if we are talking about the different types of the manufacturing processes, then it can be classified in like what we have discussed in the content part, that is casting, then welding, then machining. Okay, so casting, like, there are we are just melting the material, and that melted material we are pouring in a pattern or the mold cavity, we can say. So we are just filling that mold cavity, and once it will be solidified or become solid, after that we are just removing from that mold cavity. Okay, so that will that solidified pattern, that solid pattern, we are calling it as a casted pattern. Okay, so this is basically the casting process, and there are many things which we will going to discuss in today and tomorrow and day after tomorrow on next classes. Okay, then there is a welding technology. So it is basically a joining process. There are different types, similar or dissimilar methods can be joined by different types of the techniques are available. So that we have discussed, just I briefed you in the last class, so that we will discuss in brief, and we'll discuss the welding technology. And then the machining operations, because when whatever the product that you have manufactured using the casting process or the welding process, if it is not satisfactorily, if the dimensions and the shape of this or the tolerances, okay, or the surface finishing is not that much quite satisfactory, then we have to use the machining operations. Okay, so there are different types of the machines are available through which we are using the different types of the tools, and we are applying these machining operations over the casting and the welded part, or simply like whatever the where we have to reduce the size or dimensions. Okay, so that we are using, and so this is basically the types of the manufacturing processes. So in one more term that I mentioned in other words, like casting is basically whatever the material we have, or we just have to mold it into the other category. Mold means like this is the casted pattern or billet, we can say. Billet means whatever the cross sectional area, whatever the cross sectional area it has, it will be throughout. Okay, so if this is a kind of billet, okay, or a small in size, so if this is a kind of metallic billet, then we are just melting it. And if we want to convert in this pen, so accordingly we are making a pattern of this pen. Okay, and then we are creating a mold cavity, then we melting it, and then we are filling it into the pattern. Okay, so then we are just transforming. So means there is no loss of the material. Whatever the material that we have in a solid form, we are just melting it and we are converting it into the other solid form. Okay, so this is the material. There is no addition of the material, there is no removal of the material. Means material concept or the constant will be zero. If we are talking about the welding technology, then there are two plates initially, okay, and we are depositing some amount, we are joining that by depositing some extra amount of the material, okay, by using the electrodes or flux, we can say, okay. So that we are using, so it's kind of addition process, material addition process, so this is a positive. And machining, we are removing the material, excessive amount of the material, so this is a negative process. Okay guys, so these things we have discussed in the last time. Okay, so today we are starting with the what types, why we are using this manufacturing technology or manufacturing processes operations, we can say. Then we'll go to the second unit. We'll start with the casting terminology. Okay. Actually, it's my habit, guys. Always like what we have discussed in the previous class. First, I discussed that thing. It will take just 2 to 5 minutes, 2 to 5 minutes, and then it would be better that it's better for the students to cope up with the what we have gone through. Okay, so let's start with the this one, that is manufacturing technology. So here, like if we are talking about the manufacturing technology, it contains all the operations that we had gone through, like casting, welding, and machining operations. Okay, so like initially, whatever the raw material we have, it raw material can be in any form. Okay, raw material can be in any form, whatever the forms that is available to us. It can be a sand, it can be a metallic powder, it can be a, like metal rods, anything can be happen. Okay, and we just have to convert them into the required shape and size. We just have to convert them into the required shape and size, shape and size. Okay, so how we can convert? Either like if the raw material is available, so raw material, like if we are, as I mentioned, that this is a raw material. So if I have to just convert that into the pen, so I will apply this, I will melt it. So for that I will use the casting. Okay. Okay, for an example, now I have like I have this pattern I have created. Okay, and this pattern I have created, and just whatever I'm expecting that the dimension of this is large. Okay, so what I have to do, I have to go for a machining operations. Okay, so if I have to go for the machining operation, then I have to apply the machining here itself. Okay, so okay. And then if there is a need to join the two plates are available and required shape is like to both the plates should be joined, so we can apply the welding process. Okay, so these are nothing but the manufacturing processes only. Okay, this is manufacturing processes. Okay, so what initially we have just raw materials. Okay, this raw material can be in any form. Okay, it can be in any form. We are just applying different types of the manufacturing processes which is available to us, and finally we got the required shape and size. Okay, so this is the meaning of manufacturing technology. Okay guys, so by the way, I'm not discussing here the casting, machining, and welding in detail. Just I'm briefing you, because already we have to cover that into the different types, different chapters. Okay, so I'm just adding that one only. So this is a simple definition of the manufacturing technology, that whatever the raw materials that we have, we can convert that into the required shape and size by using the different types of the machining operations which is available to us, or processes which is available to us. Okay guys, so
Good
let's
morning, sir.
start. Yes.
Good morning, sir.
Yes, good morning Arshad, how are you?
Sir, fine. Actually, can you please confirm us class timing? कब तक चलेगी class?
uh,
Actually, हमारा clash आ रहा है उधर department.
okay guys, so let's start with the first unit, which is a very basic, that is uh, casting technology, or casting, we can say. So this is the content part that we are going to discuss. But guys, if you will see the syllabus that I have shared with you in uh, Google Classroom, okay, that is आपको जो आपका कास्टिंग का सिलेबस राइट करना था उस पे मशीनिंग का है, सो दैट्स जस्ट mismatched. वो basically that is not of casting in the fundamental of manufacturing process, if you will see. So that's why I have changed, I also added this part as well, this screenshot into that. Okay, so this is basically related with the casting. Okay, so this subject, this casting syllabus is from like we have in mechanical engineering, that is a manufacturing processes subject. So this is from that, but this is a detailed, but I'm not teaching you in a detail. I'm just briefing you that so that you can you have some idea that what is the manufacturing technology and all these things. Okay, so I'm not going into detail part. I'm not going into discuss that whatever the problems that has been asked previously in the gate or engineering services, not to you guys, but I'm just briefing. Okay, so first of all, like this is the content. So we'll study about the casting definition as so what is the meaning of casting exactly. Okay, then we'll discuss about the casting terminology, that there are different types. Before going to casting, it's like if I simply saying the definition, that we are, it's just like we are melting the material and we are depositing it into the mold cavity. So after some time, this mold this liquid form will become solid. So that is a casted product, but this is a simple definition. Okay, it has a lot of meaning. So for that we have a different types of the casting terminology, because there are different types of the elements are there. So that we will going to discuss. After that we'll discuss about the patterns and the pattern allowances, that for the casting we have to like we are using the mold cavity. So how we are creating this mold cavity, what is the need of that. Okay, so that we will discuss, and then we'll go to the molding sand. What is the molding sand that we are using? By the way, maximum of you are civil engineering, so you are aware about that properties and the sand, different types of the sand that is available. Okay, but guys, in specifically this topic, you know much better than me. Okay, but I'm just stick to the casting of metallic only. Okay, here we are not casting other things. Casting here means just we are melting the metallic rods or metallic any metals. Okay, then we are depositing. It's not related with your civil engineering. Okay, please do not confuse. Okay, so that we will discuss the molding sand, the composition and their properties. Okay, then we will discuss about the gating system. So that gating system is means here we will discuss the term gate, and gate is not like that examination. I'm not talking about that one, but a term is there. So how that gate has a different kind of system, and with respect to the different uh, locations. Okay, altitude or not altitude, locations, we can use this gating system. So that is divided, we will discuss that. Then we will I will just brief you about the metal casting processes, because there are different types of the metal casting processes through which casting can be performed. But as I said, that this is not that much important, so I will just brief you in a single class only, that what are these casting processes are available, and how we can use it. Okay, then we'll discuss about the solidification time calculation. But this time calculation, I will just brief you about what is the formula for that, and how we can calculate the timing, solidification timing. And I will not go into the detail that much. Okay, because this is not that much required for you guys. Then we'll at the end we will discuss about the casting defects. Okay. So today I will try to finish it up to this pattern and the pattern allowances. Okay, in the next class we will discuss about these two, and then it's like 3 to 4 classes. This uh, this unit will be over. Fine, so let's start. Guys, I will give you the time. If you have any doubt, like by the way, you can just unmute yourself and you can ask me in between, but I will give you the time up after this one. Okay, casting terminology. Okay guys, so let's start. Fine. So this is the casting definition. Okay, this is the casting definition. What it mean is, casting means the pouring molten metal into a, first of all, I'm just reading this definition. Okay, then I will tell you what the exact meaning of this is. So casting means pouring molten metal into a mold cavity. Okay, there are different terms is there, please focus here. That casting means pouring molten metal. Okay, first this term, then into a mold cavity. Mold cavity is important. Okay, of the shape to be made, means whatever the shape is required, that we have to make the mold cavity, then we are filling the uh, pouring the molten metal. Okay, and allowing it to solidify it. Okay, allowing it to solidify. After the solidification, the desired metal object is taken out from the mold, either by breaking the mold or taking the mold part. Okay, the solidified object is called the casting. So now I'm just okay going to detail that first of all, what is the pouring molten metal? Pouring molten metal means the, like if you will see this figure, then this red one is basically here it's red or white you can say, but this is basically the molten material because it has a very high temperature. So when you will see at very high temperature this metals is looks like this only, okay, this white color in shape. So this is the molten material, okay. So now molten material, now pouring means we are pouring it somewhere, okay. Pouring means up, just you are bringing it outside from the container or crucible we can say. This shape in which we are molding the material, we call it as a crucible. Okay, this crucible. Now this crucible in which the molten material is basically this metal is melted, and this is, if you will see the bottom side, this is basically the pattern. Okay, now from top from here if you will see, then this is like from top view if you will see from this one, then it will be looks like this one. Okay, so this is solid, okay, and this is hollow inside, okay. And when you will see from the front view it will be looks like this. Sorry. So this is solid and this is hollow, okay. So in between we are keeping it somewhere, okay, on the molding sand only. So this is like we are filling this we are just pouring this molten material into this one, okay. We are pouring this molten material into this one, okay. So this will become this will completely filled, okay. And like if it is completely filled, then we are keeping it up to the solidification time, or we are just solidifying it. Solidifying is not a different process, it's just like we are keeping it for some times, means the once the molten material is filled, we are just keeping it for some times in a place where like atmospheric gases like that should not be react with each other, so otherwise it will form the oxide. So we are just keeping it for some times, and after it solidify means the liquid metal is trying to convert into the solid form, okay. So this is the pattern is basically the uh, this from liquid to solid form, this is going, we are calling it as a solidify. Now in between there is some solidification range is there. Solidification means it's kind of, it will become a semi solid, okay. It will become a semi solid because this liquid is going to convert it into the solid, so no doubt it will become some semi solid somewhere, okay, in between some temperature range. So after this, like after the solidification, the desired metal object can be taken out, but again it depends. If it is like generally the solidification start near to the boundaries, okay, near to the boundaries. So first it will start, then only it's mentioned. मतलब इसका जो यहाँ पे रिटर्न है, that is after the solidification the desired metal object is taken out. Okay, इसका मतलब सिर्फ यही है कि ये जो आपका exact outside periphery है, that boundary should start become solid first, then internal matter is there, the internal solid liquid material is there, that will be solidified with respect to time. So if this is solidified, this outside boundaries is completely solidified, after that you can remove this material and you can keep it for some times, okay. But you should be keep it on somewhere like the shape will not be changed, because if the liquid material is there, so definitely it will try to propagate, okay. It will try to push these solid boundaries. Here it's solid, but when you will take it out, it will be looks like this. When you will take it out, it will be like this, okay. So if these boundaries is become solid and here it is liquid, then it will try to push this boundary, because now there is no solid edge, okay, outside this periphery. So either you just keep it for the solidity, it will become complete solid, after that just bring it out, or after the solidification if you are keeping, then please keep in mind the shape should be restored, okay. So the after solidification, the designed metal object is taken out from the mold. Okay, this is basically the mold, or this white color here is basically the mold. Okay, either by breaking the mold, if it become completely solid, then you, if it is not coming out from the mold cavity, then what we have to do, we just have to apply some hammer over outside over the this pattern, okay, or mold cavity we can say. So this is a way, either we can break this one or taking out the part simply, like if it is still in solidified form, semi solid form, so it can come out easily, okay. So this is like, this is semi solid or solidified object, we are calling this red one as a casting, okay, or casted product we can. So this is basically the definition of that. Okay, so let's read it once again. That casting means pouring the molten material into the mold cavity. Is it fine, guys? Of the shape to be made, whatever the shape that is required, and allowing it to solidify. Once it will be solidified, the metal object is taken out from the mold cavity, either by breaking if it is completely solid, or just taking out if it is semi-solid in form. Whatever the semi-solid or the solidified form that is taken out, we call it as a casting or the casted product. Okay, guys, so this is basically simple definition of the casting. Okay, so let's move to the next one. So next is the casting terminology. Okay, guys. So first of all, how I'm just briefing what are the elements are there. Then I will go to discuss that how it works exactly when we are pouring the molten material. So how it will work exactly, how it will flow. Okay. So this is like if you will see this one and this one. So this is two separate part basically. Okay, guys, this is the two separate part. Okay, and in between there is a parting line. Okay, so parting line is just like it's just dividing these two parts. Okay, so this is the parting line which is dividing these two parts, and the top part, this is the part above the top, about the parting line, that is the top one. So we are calling it as a cop. Please keep in mind this is a cop. Okay, and the bottom part of this parting line we are calling it as a drag. Okay, so cop and the drag. Sometimes sometimes in the casting we use three parts. Okay, so first will be the cop, top one. The bottom will be drag, and in between there is a, we are keeping third part. So this is a cheek. This is a cheek. Okay, so now this cheek is equally dividing this parting line. Okay, guys, so no need to confuse. Okay, cop is the top, drags the bottom, and intermediate there is a cheek. Okay, and cheek is dividing equally this parting line. Okay, guys, so next is uh, okay, so this is basically a kind of we can say trunk. Okay, trunk जो होता है आपका संदूक या फिर बॉक्स जिसको बोलते हैं हम लोग. So that is trunk is there. So trunk में क्या होता है, ऊपर का जो पोर्शन होता है that is a small, and bottom portion जो होता है वो थोड़ा large होता है, means डेप्थ उसकी थोड़ी large होती है. But here if we are just defining these two part, cop and the drag, then both have a same depth. Okay, means height and the depth. This is height and this is a depth, so both have same height and the depth. Okay, guys, no need to confuse. It's exactly looks like a it's exactly like a trunk only, but in the trunk, like, top part is very small thickness, very small depth, and bottom part is high depth. Okay, but here it is equal in depth and height. Okay, so this is the cop and the drag. Once it will be blocked. Okay, after this this area is filled with the sand, molding sand we are calling it as a, this area is completely filled with the molding sand. Okay, this area is completely filled with the molding sand. Now let's discuss one by one what are the parts are there. Okay, so first this part, this curvature is is we are calling it as a pouring basin. Okay, next to this, the taper section is there. So this taper section, or it's exactly looks like this. Okay, so this is the kind of taper section we are calling it as a sprue. Means after the pouring basin there is a sprue. Okay, after this is uh, sprue. Okay, this is a kind of shape is there. We are calling it as a skim ball. Okay, this is the skim ball, and after this we are keeping a horizontal path which is a runner. We are calling it as a runner. Okay, by the way, sometimes this skim ball is not mentioned in the book, so you can directly say that first there is a pouring basin, then there is a sprue, and after the sprue there is a runner. Okay, so this is the runner, and up to this is the runner, horizontal passage of cross sectional area same cross sectional area, and after that there is a gate. Okay, this is a gate. Gate is simply like we have a doors, In another words, we can say like gate as well. So what is the purpose of door? We are just opening it, and we are either moving outside or coming to the room or any area. Okay, so this is the gate, okay, through which the molten metal is passes. And gate, we are calling it as a gate because just we are calling it as a door. Okay, backside my is door is there. So why this door is there? Because either I have to move out or I have to come inside the room. Okay, so if I want to come inside the room, immediately we are keeping a door at the entry or the gate, we can say. So this gate is just allowing the solid molten material to enter into the mold cavity. Okay, so here it's this mold cavity is like this in shape. Okay, this is the mold cavity. Exactly, this is the mold cavity we have to create. So if you will see from the front view, it looks like a rectangle, but it's exactly not a rectangle. From when you will see from the top view, it will look like a circle. So now you can see it's a cylinder. Okay, this is a cylinder. Okay, so cylinder you are keeping, when you will see from the front view, it looks like a rectangle only. Okay, so this is a cylinder. Now this cylinder is completely like free from any environment, like only some kind of gases are there. So what we have to do, this is empty. So if this is empty, then whatever the material, molten material is passes through the gate and enter into the mold cavity, they start filling this mold cavity. Okay, then there is a gas vent we are keeping, and top of that, this mold cavity, we are keeping this riser. Okay, so this is the mold cavity, and top of that we are keeping this riser. So these are the basically the elements that we have to be used in the casting. Now let's look how this exactly is working. Okay. Okay, so this is a pouring basin. We are calling it as a pouring basin. Reason is through is basically we are pouring the molten material. Whatever the molten material is there, we are just keeping a passes through that. देखिए guys, generally what is happening that if like there is a tap water is there, tape is there. Okay, and we are just keeping a bucket over this tap, sorry, below to that. Okay, and we just, as we turn on this tap, the water is start coming, and this is falling in the bucket. Okay, so as it is a water, so there is no issue whether there is any kind of turbulence or what kind of bubbles is formed. There is no issue for that because that's water, and this plastic is there, so it has a more density than means high strength. So whatever the that water is falling from a specific height in our bathrooms, so that can be resisted by this plastic or the bucket. Okay, but here we are not talking about the water or any fluid. We are talking about the molten materials. Molten materials means which has which is at very high temperature. So if it is this liquid form, is it very high temperature, and if we will pour like how the water is coming, then definitely there will be a lot of turbulence, and it's not looks like you are filling this molten material, so after till half an hour it will be in the liquid form only. No, 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 no. Is whenever you will when as you will bring it out from any crucible or from any heating furnace, it will, the range of this liquid from the liquid to solid become very high. Rate of transformation from liquid to solid is very high. Okay, so it's not like the water is coming and that is falling in the bucket, so water is filling, that complete bucket is filling, so bottom part is still water only. But it's not like when you are falling the molten material, whatever the molten material that is first initially kept over this bucket, when it will fill, the bottom part is completely become solidified. Okay, so this is a very high rate of cooling or contraction or cooling, we can say. Okay, so here we are using this pouring basin. Now this pouring basin we are keeping sometimes in this shape, or exactly if you will see, then it will be in this shape. Sorry. Exactly, some this will be in this shape. Okay, exactly looks like this one. The reason is we are pouring the is we are keeping this crucible over here, and we are this pouring the molten material, it will fallen over this boundary. Okay, is it will fallen over this boundary. So we are just providing a passage or path, we can say. Okay, if this is a kind of shape that we have created. So we are just pouring the molten material, so it will first fall over here and then it will follow the path. Okay, because it has a very high density, so it will follow the path. So it will collect over here, it will collect over here, and then up to this specific height it will reach this molten material, this filling, and then this molten material this passes through this area. Now this is next to that, there is a sprue is there. Okay, so the sprue is in the taper in section. The reason is of the tapering section is to protect the casting from the air aspiration effect. To protect from the air aspiration effect. What is the meaning of this air aspiration effect is, and what is this? Like is we are feeling is we are is we will keep okay, if we'll keep this key crucible over here, so if we are pulling this putting this pouring this molten material from this one, then it will be directly fall like this. Okay, so what is happening exactly here, that molten material is already there and you are providing free fall to that. Okay, so if you are providing a free fall, then definitely there will be a lot of disturbance, as well as the casting should not be proper. Okay, and the second reason is to avoid this one, that we are keeping this taper in section, is the air aspiration effect. Reason is, if it is not a taper in section, a taper in section means at the beginning of the sprue the area is large, at the end the area is small. If the area is become small, the velocity is increases. Okay, so if the velocity is increases, then it will start filling this one, this runner. Okay, this molten metal which is passing from here, it has a very high velocity as comparatively over here. Okay, because the cross section area has been reduced. Now the cross section area has been reduced, there is another reason for that, that is you are keeping this, you are filling this molten material, right? So if you are filling this molten material by using this sprue, so we have provided some specific mass flow rate or volume flow rate, we can say, the material volume flow rate, we can say. So if it is coming little bit, whatever the flow rate which is required over here, if it is coming with a high flow rate, then what will happen, it will become start depositing over here. So it will start depositing over here. So it, what it means is, there will be no space for the air to contact or to deposit in between the molten material. If this air will become in contact with the, means if this air will come in contact with the casting, then it will make the porosity, it will create the porosity, and this porosity is nothing but the casting defect. What is the meaning is porosity? Like this is the casted product. Okay, and here this porosity is formed, this is completely solid, this is completely solid. Okay, and these are just three bubbles, the three porosities has formed in between the casting. So what will happen, this is nothing but a kind of bubble only, a bubble of air, means air is entrapped. Okay, now this air is entrapped, so what will happen because of that, because of that the strength of the material, that casted product is decreases. Okay, because if, just for an example, that if this material was if this air bubble was filled with the mold cavity, then definitely there is a good strength. But now the bubble is formed, the air is entrapped, so the strength of this material is decreases. So we do not want the entrapment of the air, and entrapment of the air, that will create the casting defect. So that's why we are just keeping this shape of this sprue in taper in form. Okay, and in other words, whatever the formation is there, we are calling it as a air aspiration effect. Okay guys, after that the material which is coming through this sprue, we are calling we are using this skim bob. So if it is directly falling, so if it is directly falling, then it will fall up to here, and then because this height is the runner and the skim bob has some specific height, the difference of this specific height. Okay, so this material will be deposited over here, molten material, then it is passes through this runner. So this runner is there, this is a horizontal passage, okay. And this runner also we are using because now the material is moving horizontally. So what will happen in the material, the more density particle will try to move at this area, okay, will cover in this region. The more density particle which has a very high sorry, a particle which has a very high density, they will try to move at the sediment over the bottom of this runner, and the particles or the molecules which has a low density, they will try to lift it at the top position here, okay. So this is like this is bifurcating this runner. In other words, we can say this is bifurcating in the high density particle and the low density particle. Okay. Now, but that does not affect that much because it's the same material only. It's not like we are adding some alloy bit in between. Okay. So if we are adding the alloy, then here also we have to provide some kind of steer. So there's a proper mixing can be placed. But I'm not considering that one here. It's a simple material is there, and we are just moving it up through the runner, okay. So after the runner we are using the gate. Now if you will see, the cross section area of this gate is decreased as comparatively with the runner, okay. As comparatively with the runner, the cross section area of this gate has been decreased. Why it we have decreased? To increase the velocity, okay guys, to increase the velocity. So we are just keeping like initially, if this is same like the runner cross section area, then it will just fall. But now it has a velocity, so it will just try to move like this, okay. So okay, so this is the great gate cross section area through which the molten material is coming, and this is the mold cavity. So this is a cylinder, hollow cylinder we can say. So first, as the molten material is fallen, so first it is covered this area, and then it will start filling this one. Okay, guys. So now please keep in so okay, let's first then it will fill this area, okay, and rest this molten material start coming out from this one. Is it will come out, we know that now the mold cavity is completely filled, okay. So now we can stop this pouring the molten material from here, okay. So this is the meaning of this casting terminology, or these the elements that we are using. The meaning of that is this one, okay. Now here the important thing is by the way, this is just a simple meaning, but here we can add. There are a lot of questions is raised from here. Now, is first the molten material which is falling over here. First, it is covering this cross section area or volume, we can say, because it is at the top. Sorry, it is at the bottom. Now it will move first. Then it will cover this area. Then it will move toward this side. But how it can move toward that side? Okay, because this area is already covered and molten material is coming from this side. So how this molten material will go to that side? it, the molten material which is recently coming from this area is not can be lifted directly, okay, because that cannot be lifted either. What we have to do, we have to keep we have to create the mold cavity like this, right? We have to create the mold cavity like this. So what the molten material we are pouring, so first it will be fallen like this and it will fill, okay. And if this material is filled completely, the molten material is coming from this area, this riser we can say. So but we cannot keep like this, okay. The reason is because here the molten material will be fallen, and if it is fallen, then definitely there will be a turbulence, okay. Turbulence means because it is a very high temperature, it's not a water, okay, which is at atmospheric temperature, it is at very high temperature. So that will create a very turbulence, and in which basically mold there is a chances to breakage the mold. So through which we cannot fulfill our what aim we had, okay. So what we are doing is, okay, so up to this material is filled, okay. As the liquid material is coming from this side, this area is filled. As the liquid material is coming from this side, so whatever the liquid molten material is there, it will try to lift it up. It will try to lift it up, okay. This is lift it up means Initially this molten material is at the top. Now the new form is came, so this is become the bottom of that. It's like that. Okay, the new material which is coming, it will just try to come at the bottom only, and the previous one that is lifting from up to here and here and here. So here as it is coming out, so this material, which material it is? It is not the material which is recently added. It is the material which entered at this area, at this cross section area, when the molten material height was this, when the molten material height was this h, we can say. Okay, so this at the molten material which is coming out from this area now, or riser, we can say, this is filled before, sometimes it not recently filled. So whatever the molten material that is coming out, that should be either, because that is coming out of it, obviously that will be in the liquid form. And as I said, the molten material that you are filling, as you are filling it inside, it will try to the cooling rate is very high, so it will try to become semi solid. So the material, the material which is coming from this riser, it is in either liquid form or semi solid form. ओके गाइस, इट इज नॉट बिकम सॉलिड, अगर सॉलिड हो जाता तो बाहर ही नहीं निकलता, ठीक है. सो इट इज इन आइदर लिक्विड फॉर्म और एंड solid form. Okay guys, so this is basically the concept of that. Okay, so I'm just briefing you that what these elements are. I have the definition for that for you guys only, because I will give you this PDF, so it will be easy to understand you. So the pouring basin, first is the pouring basin, the small kind of funnel shaped cavity at the top of the mold into which the molten material is poured. Why the molten material is poured? Because we want that the molten material that we are pouring, it should follow the path. Okay, it should not be fallen. Please keep in mind the sprue. After the pouring basin, the passage through which the molten material from the pouring basin reaches to the mold cavity. Okay, or runner also we can say, runner also we can say. But here like, is you are not from mechanical engineering, so for the time being just keep it that after this sprue there is a runner only. Okay, so means sprue, the purpose of sprue, it is just passes the molten material from the pouring basin to the runner. Okay, the runner is basically the horizontal channel through which the molten material is carried out from the sprue to the gate. Fine. Gate is a channel through which the molten material enters into the mold cavity. It's okay. After the runner, we are keeping the gate, and then there is a mold cavity. The riser is a column of the molten metal. Means it's like a it's a kind of opening area only, but the molten material which is coming out. Okay, so column of the molten material placed in the mold to feed the casting as it shrinks or solidifies. That I will tell you in the solidification casting. Okay, what is the meaning of shrink and then it solidifies. Gas band, yeah, here one more thing we are using, that is a gas band. Okay, so gas band is the because of the same reason that I told you here, that still like this shape is there. So you can ask me that sir, initially you are not filling the complete cross section area by using the molten material. So obviously, yeah, my answer will be right, you are right. Okay, my answer is like you are right, because this completely not, this cross sectional area is not completely covered by the molten material, so that complete the molten material is falling from all side. It's not like that. Okay, from the specific side only we are depositing the molten material. So obviously this much cross sectional area in the beginning is vacant or empty, we can say. So there is a chances to entrapment of the gases. You are right. Okay, but we are using the gas vent. Now either you can use this gas vent at the mold cavity, or you can connect it up to from the runner as well, sometimes from the gate as well. So what is the meaning of gas vent? That if any kind of gases is entered through this one. Okay, so definitely like this is at very high temperature molten material. So if the gas will rate it at because obviously the metal is also releasing some kind of gases which is at very high temperature, because that is radiation is occur because at very high temperature. So because of the radiation, whatever the gases that has been came inside, now they are went through the gas vent. Okay, means just left out the mold cavity by using the gas vent. So this is just a passage through which we are just removing the gases or air, we can say. Okay, so gas vent is just a small opening in the mold to facilitate the escape of the gases or air. Okay guys, okay, so guys, can you tell me what is the difference between this figure and this figure? Any one of you, You can just unmute yourself and you can tell me. First, this figure, and second is this figure. What is the difference? Can you tell me? Any one of you guys? I am expecting that you are listening me.
Sir, in the second figure, we are using chaplets in order to increase the rate of directional solidification.
Right. But good. Roman is also good. But guys, these we are keeping these chaplets. Okay. Why we are keeping these chaplets? And there's a one more thing, that is a core. Okay. So why we are using this core is, if like for an example, if you will see the last figure, if you will see this figure, then this is, as I said, that this is a cylinder. Okay, from top view if you will see, then it will be looks like this. Okay, so this is exactly looks like this. Okay, so what we are doing is we are just filling the molten material. So if we are filling this molten material, this is completely filled. So what we can say is the shape that is formed by using this mold cavity is basically this complete solid. It's not a, there is no hollow section, it is completely solid. Okay, now what we are doing is, if we want to create a kind of uh, if we want to create a hollow part. Okay, this is, just assume that this is cylinder only, this is cylinder only, this is from front view it will be looks like this, from front view, and from top view it will be looks like this. Okay, the this one. And now what we have to do is, in between we have to create some hollow cavity. I want to keep some hollow portion. Okay, and it should not be like a hollow cylinder, because hollow cylinder means is like this. Hollow cylinder means like this. Okay, so this is like the semi boundaries. Boundaries are there of some specific thickness, and inside there is a hollow portion is there. So this hollow portion is throughout the length, whatever the height or the length we have. So this hollow portion is throughout this height. Okay, so this is not a, what we are creating is, this is not the hollow cylinder, but whatever the cylinder, solid cylinder is there, in between we are just trying to keep a semi uh, we are trying to create uh, a free space, we can say. Okay, now this free space is same like in a cylinder in form. So when you will see from front view it will be looks like this, a rectangle, and when you will see from the top view it will looks like this. Okay, so this is a circular in
Sir,
nature.
core actually create
Yes, yes, Irish.
core actually creates the hollow cavity.
Yeah, that core we are using, just if we want to create the hollow cavities, for that only we are using. Okay, so this is the mold cavity. Okay, and the difference between the last figure and this one, that here we are using the core. Okay, now this core is generally made up of, this core is generally made up of the molding sand only. Why we are using this molding sand, why we are not using the wood or the material? The reason is, like, if the molten material start filling this mold cavity, then this will be filled. Okay, this completely is the material is filled. Okay, and the material will be come out through this, so we'll stop this pouring this molten material. So can you tell me that, can we remove, once this solid material is completely filled, can we remove this core from inside? We cannot remove. Okay, that's why we are not using. If like for an example, just for an example, that I have the sharpener. Okay, so I'm just considering this as a core. Okay, and I'm just creating a ball. Okay, this is a kind of ball is there, or a solid ball is there. So I want to keep cavity in between, hollow cavity, okay, hollow cavity in between. So we are just holding this one, and wherever this space is hold up, okay, this is like wherever it will be, there will be a hollow cavity. But when it will become completely solid, can I remove this cavity? I cannot. I cannot remove this cavity. So it will be like if we are using the wood, if we are using the any hard material, then it will become a part of this. So what we have to do, we do not want that it should become a part of that. So that's why we are using this molding sand. But again, you can ask me one question. मोल्डिंग सैंड है तो क्या हुआ, मतलब सस्ती है तो आप उसको अंदर ही छोड़ देंगे क्या? नो 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 नो, वी आर नॉट लीविंग इट इनसाइड, वी आर ब्रिंगिंग इट आउटसाइड. But after that, what we are looking is what is the small area is there. So if like there are two areas, first is there are two areas, like first is this passage, okay, once this area is there, so either we can drill it here, or what is this area. So if we will compare this length and this length is small, okay, so what we are doing is we are using a drill bit, a very small size drill bit, and we are just drilling it. Once this is drilled, okay, then we are what we are doing is we are using the different types of the casting elements are available, so that equipments we are using, and we are just digging it inside, we are just digging it inside, or sometimes we have to use the hammer, then we are using the hammer as well. So what will happen because of that, whatever the molding sand is there, they will basically breaks, okay, and they will breaks, and we are just tilting it and just removing that sands by using this one, okay, by pushing and like this, okay. So this is we are just removing this core, okay. So this is a way through which we can create the hollow cavity. But here, one more important question is chaplet. Why we are using the chaplet? Okay, so why we are using the chaplet? So as I took the example of this sharpener. Okay, so this is the mold cavity. This is the cavity, hollow cavity means I have to create the hollow cavity of this size. So if like I want to create a spherical ball. Okay, so where I will hold it? Like for an example, I want to create this hollow cavity over here, but as I will drop it, means as I will leave it, it will fall. As I will drop it, it will fall. Now, always be, if I'm doing this process, then it will always be at the bottom of the surface. This is always, this hollow cavity will be created always at the bottom of the surface. But I do not want that. I want this to be at some specific height. So how like how I can hold it? So for that only we are using the chaplets. Okay, so this is the chaplets to hold the core part, to hold the core parts. Okay, so this is a mold cavity, means this is the side by side, means outside there is a molding sand is there. So what we are doing is we are using the chaplets of whatever the dimension or shape that is required to hold this one. So we are just using these chaplets to hold the core. Like here I'm using the four kind of chaplets. Okay, now this is one side, it is connected with the molding sand which is over here, and another side is also connected with the molding sand, but here we are calling it as a core. Okay, so this core is connected with the chaplets, and this chaplet is connected with the holded by the molding sand. So now you can hold anything over here. Okay, it's like this one. It's like this. Okay, so this is just like if you want to hold this area, then we can just hold it. Okay, this is just one chaplet, we can use three more chaplets. Okay, so chaplets we are using, so this chaplets is used to hold the core part. Now there is a one more question is there, that okay, let's suppose now you are filling this molten material or mold cavity we can say. Okay, now you are filling this mold cavity, so this mold cavity will be filled. Okay, like after drilling, once it will be completely solidified after drilling, we can remove this this material, core material. Okay, because uh, that is the cavity, hollow cavity that is needed. But how you will remove these chaplets? Can you tell me, guys? How you will remove these chaplets? Can we remove these chiplets or not? Or if we can remove, then how? Okay, so by the way, guys, we cannot remove these shaplets. We cannot remove anything from the core. Okay, from the mold that solidified casting pattern. We cannot like anything we can remove. We can remove the core because that is a molding sand. But if we cannot remove, then please keep in mind that chaplets is providing the support to the core and it cannot be removed from the workpiece material, but like from the casting material. So what we have to do, like if you are using the aluminium, okay, if you are using the molten material of the aluminium, then you cannot use the chaplets of the mild steel. Okay, please keep in mind, there are different types of the material. Aluminium is also one among them, metal is also one among them. So if you are using the casting of the aluminium, molten material of the aluminium, then for an example, we can use these chaplets. We cannot use these chaplets of the mild steel or SS or any other material. We have to use these chaplets of the same material or same grade. If we are using any specific types of the grades of the aluminium, for an example 6061, then these chaplets will also be manufactured by the 6061 of aluminium only. Okay, because it cannot be removed from the solidified part. Okay, so please keep in mind. Fine. So this is the core we are using to create the whole hollow cavity. Chaplets we are using to hold this core. Okay, please keep in mind. So core is basically a separate part of the mold made of sand. Okay, this is of molding sand and generally backed used for making hollow cavities. Okay, chaplets are used to support the core inside the mold cavity to take care of its own weight and overcome the metallostatic forces. Metallostatic forces is written, the reason is like, yes, you are keep filling this molten material over here. So basically as the molten material will filled up to this, it will try to lift it up because it's also has a very high density, means the molten material. Okay, so it will try to lift it up. So if जो आपका strength है that is not provided properly by this chaplets to the core, then it will be lifted up. Okay, so that will be disturbance. Okay, means if this is chaplet, you have hold over here this core, and because of this metallostatic force, matlab metals, the force that is lifted by this metals, if it is lifted up, then the direction is changed, means the dimensions has been changed. Okay, so we have to keep in mind that thing. Okay guys, so these are the two things. Now just for the easy purpose only, I'm using one more figure of this one, because if you will see these two figures, then these two figures are available in any of the books. But just to understand that what is the casting exactly is, I'm using another figure. So this is the figure that is a kind of it's a kind of that cone. But if this is not exactly the cone, okay, this is exactly not the conical shape, because this is exactly the conical shape. Okay, so in between, only in between somewhere only we have cut it. Okay, so this is a kind of this part is not there. Okay, so only this much. So from here the molten material start filling, so we are using this core. Okay, so because we have to make the shape like this, so same of just replica of that, this is same of same object kind of that we are making this pattern or the core we can say. Okay, so this pattern is formed, and we are using this as a chaplets, okay, of the same material that we are filling. Okay, so this is like once it will be solidified, it will become this one. Okay, so please keep in mind this. Okay, okay, so next is we are going to pattern. So I'm giving you just 1 or 2 minute time. If you have any doubt, you can ask me guys by unmuting yourself.
Sir, we are using cope and drag, and in between you mentioned about the cheek. What is the function of cheek?
Arshad, are you asking what is the meaning of cheek, right?
ये function, what is its function?
Function of the chick. Function is it's like if you will see this one, then it looks like we are just providing outside boundary. Okay, outside boundary to the molding sand. Okay, this is the molding sand is filled is there. Okay, this is the molding sand is filled in this area. So why we are filling this molding sand? Because if we are inserting these elements like pouring basin, we are inserting sprue, we are inserting runner is there. So it's not like we can hang it somewhere. Okay, it's not like pouring basin is in air, then a sprue is there, then runner is there, then gate is there, then mold cavity is there. We cannot hang it because whatever the molten material that we are filling, it is at very high temperature and high density as well. So definitely there will be a turbulence if we are hanging this elements into the air. So what we have to do, we have to provide we have to provide the support of the material. Now if we'll use any kind of the material, like if we are providing this support to the by the wood, then there is a chance to burn this wood. Okay, or if we are using any kind of material, then there is a possibility to melt this wood. So, but what is the possibility that if we are using the sand, then it will not melt? The reason is that is a silica. The sand is basically a silica. So that will not, whatever the temperature, high temperature you will provide, that will bear, and it will try to protect the boundaries of this cavities or the pouring basin or the sprue, we can say. Now there are two elements through which basically we can provide the support. Because if you are providing the support of the sand, then how much you will fill? There is a lot of space in this room, like we can fill this completely room, but we have to be some extent. Okay, there is some constraint is there that how much sand you will fill. So for the specific range of this sand, okay, like we have 5 kg, 10 kg, 15 kg of the sand only, so we cannot fill complete room. Okay, for that maybe it's like 51 ton of sand is required. So if we have this 15 kg or 10 kg of the sand, then we are filling it in a trunk. But the only difference between the trunk and this cope and drag part is, ट्रंक में क्या होता है, आपका ऊपर का जो पोर्शन होता है, ट्रंक मतलब जो आपका घर में बॉक्सेस होते हैं या पेटीज जो होती है ना, पेटी जिसमें हम कपड़े वगैरह फिल रखते हैं, तो उन पेटीज में क्या पेटी में क्या होता है कि ऊपर का जो पोर्शन होता है वो स्मॉल होता है थिकनेस का, और बॉटम वाला जो पोर्शन होता है थोड़ा लार्ज होता है, ठीक है. बट हियर वी कैन नॉट यूज दैट ट्रंक. ओके, हियर वी आर यूजिंग दैट top part and the bottom part, both should be in equal. So if we are using two elements, then we are calling it as a cop and the drag. But on behalf of two elements, we can use the chick. Matlab three elements also we can use. So third element is nothing but of a specific height or a free space. It's a kind of, it's like if you will see from the top view, then this is like rectangle, we can say. Or if you will see from the front view, then front view it looks like a specific height is there. Okay, or in other words I can say like this is basically the okay, this is the boundaries of this chick, we can say. So this is hollow from inside, this is a hollow from inside. But if you will see from this front side, then it will be hollow. But when you will see from this side, then it has some thickness. Okay, so this is a chick. Okay, that is only the functionality, just to hold the molding sand. Okay, that is only the functionality, and that is only the functionality of cope and drag as well.
Okay, sir. Thank you, sir.
So anybody else, anybody have a doubt? Okay guys, so let's move to the next one, that is the pattern. Okay, so pattern is let's see first the definition. Okay, patterns are used to mold the sand mixture into the shape of the casting. Means, for an example, like like for an example here, we have to make this cylinder. Okay, this solid cylinder we have to make of the casting of the specific height, okay, of a specific height and a specific diameter. So this diameter is capital D and height is small capital H. Okay, so before going to casting, before going for the casting, we are making the patterns of the same dimensions, okay, same dimensions and the size. So if like, if we have to form the solid cavity of H height and the D diameter, means solid cylinder we can say, before that we have to create this mold cavity, because in the mold cavity only we are filling the molten material. Okay, so how we are creating this mold cavity? So mold cavity we are creating, like first of all what we are doing is of the same height and the same diameter, we are creating a pattern of height h and the diameter d. We are creating first the pattern of that. Pattern means it is made up of the wood. We can say simply we are using in the wood in the workshop. So you can say wood we are using, and because wood is like, we can work easily, very easily on the wood. Okay, because whatever the intricate shapes or complex shapes that we have to form, that can be easily formed by the wood. So for an example, I want to make this kind of solid boundary. Means if I want to make this we can say this is a prismatic bar of some specific length. Prismatic bar means whatever the rectangular cross sectional area is there, it will be throughout the length. So for an example, I want to make this casting pattern. Okay, so what we are doing is, first of all, I want to create a pattern, and this is the pattern that I have created of same height, length and width we can say, okay, of the pattern wood. And then what we are doing is, if sand is filled, this sand is filled and this gate part is connected. Now just, if gate part is here, gate part is here, then near to gate I'm just keeping this one, I'm just keeping this one, and then I'm filling this molding sand. Okay, and then I'm pressing it. So this pressing means, molding sand means it's not like a simple sand, it has some liquid content as well. Liquid contents mean it will become solid, means it will become spacious or solid very early. Okay, it will try to shrink very early. So as you will provide this solid air, you will fill molding sand and you will hammer it, so it will be like the shape is formed by the molding sand. If once this shape is formed, after that you can remove this pattern outside from this mold cavity. Now this mold cavity is filled, this mold cavity is formed. After that you can fill this molten material and you can fill this mold cavity, then only we are making this solid body. Okay, but before that we have to create the pattern. So pattern is nothing but it's the same geometry that we have to create the mold or the sand mixture into the shape of the casting. Okay, the patterns are made up of the wood, plastic or the metals. We can also create, but wood is generally preferable. Reason is like it's easily available. Okay, and any shape that can be created, just we have to use the chisels and hammers. Okay, and some of the equipments, carpentry equipments we have to use. Okay, so that is very easily available. But for the plastic itself also, like if we have to, first of all we have to melt it and cast the same the pattern. Okay, that will be a tedious task for the plastic and the metals. So for the easy, wood is the easiest way. Okay, then the selection of the pattern depends on the shape and size of the casting, that what types of the shape we have to create. If we have to create this kind of geometry, then we have to create this pattern of this one. If we want to create a pane of the solid structure, then I have to create this wooden pattern. Any kind of shapes, okay, that we have to create. If I want to make this mouse, okay, by of metal, then I have to create this same geometry either by the plastic, or if it is already available in the plastic, then it's fine. Otherwise I have to create this of by the wood. Okay, so first of all I have to create the pattern, then I will fill it into the molding sand. Once the geometry is formed, I will just bring it out and then I will fill the molten material into that mold cavity. Okay, so this is basically the casting or the patterns that we are using. Okay, guys. So now for the, okay, so this is like this is the molding sand. Okay, this is the molding sand we can say. Okay, like here I just mentioned one part only. Okay, so what we can do is Okay, guys. So here, this is the parting lines. You can assume this is the part. This is this blue color is the parting line. Okay, and then we are filling this with the molding sand. Okay. Now this molding sand somewhere is filled like exactly if you will fill the molding sand, it will fill like this. Okay, like in the drag part, this the bottom one is the drag. Okay, and this one is the curb. So you can just fill the molding sand into the drag part. Okay, this is completely filled this drag part. Now the pattern that we are using, the pattern size is this one. This is the pattern, or we can say like this: the molding means solidified. We have to make this kind of pattern. Okay, so this is okay, this is the pattern that we have created. Okay, this is the pattern. Okay, now why we are creating this pattern, like is the same we have to casting. Okay, so this is of whatever the size and dimensions it has, we are just created this pattern of the wood, and this initially we are just inserted inside the molding sand which is available. Okay, so by simple force only it can be inserted. Now whatever the area that is remaining in the core part above this top, just fill it with the molding sand. Just please listen, just we are filling it with the molding sand. Okay, just we are filling it with the molding sand, and then we are just hitting some pressure force from top sides or from the side, all the sides. Okay, so it will become solid. Okay, it will become solid means this pattern should be attracted. This attracted means this molding sand is attracted just to the pattern. Okay, so once like this is made, okay, this will be done. After that what we are doing is top part is the corp, so we can keep it outside. If we're keeping it outside, it doesn't mean that this shape which is formed, if we are keeping it outside, it doesn't mean that this shape which is formed in the core part will be removed from this one. No, if you will keep this outside, then this is a core, this is the core part, this will be looks like this. Okay, this is a molding sand. Okay, so this area will be looks like this, and if you will see the pattern, sorry, drag part, then just I'm keeping aside. Okay, so it will be looks like this. Yeah. Okay, it will be looks like this is the molding sand. So this is the drag part. Okay, this will be like a pattern space that is created by the pattern space, this blank space. Okay, that is created by pattern that we are used. Okay, now after once after what, why we are keeping it aside, because we have to remove this pattern from here. Okay, we have to remove this pattern and we are keeping aside. So what we have to do, once the pattern is removed, this will be the shape will be like this only. So just we are keeping it again like this, just we are keeping it again over one over each other. So this will be like this is the core part and this is the parting line, and I'm just keeping it over here. Okay, so this is the drag part, or simply you can also say this is the drag part. Okay, so this is, now you can see that whatever the shape of the pattern that is created, that is formed, now you can use the gate over here through which the molten material can be poured, and this is the molten material will be poured. This will become solidified after some time. Okay, so this is the casting, and this is the exact meaning of the pattern that we are using. Okay, guys, so fine. So this is the pattern. Okay, and this is the molding sand. Now if you will see, just make it different, make it away, so it will like this is the pattern, and this is the, so this sand is this is the drag part. So in the drag part, this shape is formed, and if you will see in the this one, the core part, then it will be looks like this, and this type of the shape is formed in the, sorry, in the drag part. Okay, sorry, core part. So this is like free. Okay, and this is the shape that we have to cast. Okay, so just we have to fill the molten material over there. Okay, then it will be solidified, so that will become a casting. So these are the patterns that we are using. Okay, so next is what are the allowances that we can use. Okay, so there are basically there are five allowances. Okay, these five allowances are not like by name we can just differentiate. Okay, this is different and this is different, but overall the meaning is same. Overall the meaning is like just due to the small queries only we have just divided that into the different categories. Okay, so first is the total are five allowances. Allowances means uh, there will be some disturbance, or we have to provide some kind of tolerances. Okay, tolerances reason is like if I'm making this pattern. Okay, if I'm making this pattern of the wood and then I'm removing, so this much mold cavity has been created. So when you will fill the molten material into that, now this wood and the molten material has a different density, as well as when the molten material you will fill, that time initially it is in the liquid form, but as will it will try to become solid, and once this liquid is converted into the solid with respect to the time. Okay, so definitely there will be a shrinkage means it will try to contract that. It will try to either this material, liquid material, either contract or it is expand. It depends what materials we are using. Okay, and how we will remove this material. Okay, so on the basis of that only we have gone through these allowances that we have to be provided in the pattern. Okay, because if the material is contracting or the material is expanding, then whatever the dimension that we have taken of the pattern, that is not correct. Either we have to increase it or we have to decrease it. That depends that how much percentage contraction is there, how much percentage expansion is there. Okay, so that depends on that material, that what material we are using. So there are five types of the allowances. First is the shrinkage allowance, second is the draft allowance, third is the machining, fourth is the distortion or camber we can say, and fifth one is basically the wrapping allowance. Okay, so it's just we are waiting for 5 minutes. Okay, guys. So actually, this break was just for like, as I am continuously speaking from one last 1 hour, so that's why. Okay. So let's start with the pattern allowance today. Okay, or first with the pattern allowance. So pattern or the contraction allowance. Okay, so by this figure only I'm briefing you that what is the meaning of that exactly and how it is related with the riser or the certified material. Okay, so initially like we have this that xy curve of on the x-axis this is the time we are taking with respect to time, and on y-axis we are taking the temperature. So temperature we are taking means at the low temperature it is in the solid form, at high temperature it will become, so it will become liquid. So we are starting with that initially we are keeping it in a liquid form because molten material is there. Okay, so here we are keeping it in a liquid form, guys, if you are taking the example of Fe, that is iron, then it has a melting point of 1534 degrees centigrade, okay, or 35 degrees centigrade. Okay, so this is the melting point of iron, and if you are talking about the aluminium, then this is generally in the range of 900 or 950 degrees centigrade. Okay, so that will 900 is also like that. This bearing is basically due to the different grades of the aluminium. Okay, so we are can average, on an average we can consider like 8 900 degrees centigrade for the aluminium. So up to from the 900 for the aluminium, or if we are taking example of iron, then from 1534 only we are considering. Okay, that initially it is in liquid form, then we are moving towards the with respect to the time. So what will happen with that? Okay, so if we are considering that initially it is in the liquid form, then with respect to time, is initially this was. Okay, and it is the time is increases the from liquid to solidification, solidified, it will become solidified means semi solid very quickly, very quickly. That's why I told you guys that it will become, it's not like we cannot make it free fall, we have to provide some kind of support. Okay, so because the cooling rate from the liquid to this, it will become solidified, it become very fast, the cooling rate of this is very fast. Okay, so we have to keep in mind that one. So now you can see that very fast means very small time the temperature is fallen from this 1534 to, if you will talk about the uh, iron, then it is in the 910 degrees centigrade. Okay, so this is from 15 to 900 means 600 degrees centigrade it can be in the within a very time, very small time. Okay, so as it's like if this is the pattern that we have initially created and that is filled by the molten material, so this is completely the molten material, guys. Okay, so this is the molten material. Molten material means liquid material, so it will first of all these boundaries will become solid, these boundaries will become solid, then whatever the molten material that is in contact with the boundaries, they will become try to become a solid, so it will move towards inside. Okay, guys, so it will try to try to move inside. So as it will become semi solid at the boundaries, it will show you this figure. Okay, from this to this, initially it was completely liquid and it start become semi solid, and as it becomes semi solid, this semi solid formation become moves towards the center, moves towards the center. Okay, so if from here to here, all the element, all the molten material will try to become semi solid inside this space or mold cavity, we can say. Okay, so it will take time, complete become semi solid, then it will take, because the temperature has fallen, and now you have to go from 900 degrees centigrade to like for the solid 100 degrees centigrade itself has no meaning, we can say, like it will become solid at that. So like as it will reach to the atmospheric temperature, room temperature, we can say, then it will take a lot of time. Okay, that is in the here it is like liquid in form, you can say. Here it is semi solid, here it become completely solid. Okay, so during when there will be it conversion from liquid to semi solid, there will be a shrinkage allowance. So that shrinkage allowance is liquid, because liquid is converting from liquid to semi solid. Okay, eight the semi-solid only is all it takes also some time from boundary to the center to semi-solid, if semi-solid become complete semi-solid. So whatever the allowances that occurs, shrinkage allowance, that we calling it as a solidification allowance. Okay, guys, and from semi-solid to liquid, we are calling it as a solid contraction. Please keep in mind that these two are shrinkage. Okay, and this is the contraction. By the way, both is same meaning, because here we return the shrinkage or the contraction, but how it is related with this mold cavity or the pattern that we are filling, or how it is related with the riser for casting pattern. Casting of the pattern is right, that like because the mold cavity that we are leaving. Okay, so this is casting, we are calling it mold cavity, we can say. So for that, these two allowances are associated, that semi this solid shrinkage and the semi solid means solid contraction. Okay, and if we are talking about the riser, then solidification shrinkage and the liquid shrinkage is affiliated. Why this liquid shrinkage and the solidification shrinkage, I told you guys at that time, when I discuss this one. Okay, because is the liquid material is coming from this one, so whatever the material that is coming from this area, in this area, finally this is filled initially here, and now that is only lifted by the liquid material, that is only lifted by the liquid material. So as it is lifted, it is coming out from the riser. Okay, guys, so this is coming out from the riser. Okay, so this is whatever the material that is coming out from the riser, either it should be in semi solid form or it should be in a liquid form. So the allowances which is affiliated with the material which is coming out from the riser is a liquid shrinkage and the solidification shrinkage. Okay, and is we are trying to mold, means is we are filling the molten material into the mold cavity, so we are trying to make it solid, because that is only the casted product. So first of all, it will become a semi solid, so the allowances which is affiliated with that, that is the shrinkage allowance. And it will become solid, from semi solid to solid, that will be affiliated with the solid contraction. Okay, so this is the meaning of shrinkage allowance. I'm just briefing you only, guys. I'm not going into detail. Okay. Next is the draft or the taper allowance. Why we have to provide the draft or taper allowance, guys? Because for an
Sir,
example, this is the pattern. Okay, so this is the pattern that we are filling, that we are keeping inside, and then we are filling the molding sand. So when you will bring this pattern outside, so definitely the molding sand that is attached now with this one, so it will not leave it. Okay, so for that, what you have to do, either you have to push the hammer from
sir,
outside, or you have to pull it. And if you are unable to pull it, because if you will pull it, then whatever the molding sand which is in contacted with this one, they will basically become they will try to like uh, leave the space, and they will fallen inside. So if they will fallen, then Arshad, do you have any question?
yes, yes, sir. Sir,
Yes.
how we ensure that the liquid that is in this riser stays in this liquid form? How do we ensure that?
Arshad,
There are
okay.
solidification of that liquid also.
Solidification is clear, Arshad.
Yes, sir. Yes, sir. I am saying how we ensure that the molten metal stays in liquid form in the riser.
If it will become, you just tell me one more. You just answer me one question. That like if this the material which is coming out from the riser, okay, can it be possible that it, when it will become completely solid, will it be come out from the riser?
Sir?
Means when the molten material, sorry, when the material will become completely solid, is there any possibility to come out from the riser?
No, sir.
No. Then obviously, what is the possibility that when this material will come out from the riser, this will come out only. There is a two possibilities, that the material in the liquid form, and that is in the semi-solid form. There is
Yes,
these two possibility only through which the through the riser material can be come out. If
sir.
it will become solid, then definitely it will not come out from the mold
Yes.
cavity. Okay.
I am
Otherwise,
saying
what will
how
happen? Yes.
I am saying how we make it ensure that it stays in liquid form. There are chances of solidification also.
Okay. 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 Yeah. Right. 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 Yeah. This is like yes. There is a chances of solidification also, right? So, if it when it will come out from the riser, basically we are just here trying to ensure that this material in the liquid form, means liquid or semi-solid form, so that we will stop the pouring of the molten material. Okay. Now, is it is coming out from the coming out from the riser, there is one thing. You What I'm getting is like you want to ask that how we'll ensure that whether it is in semi-solid form or a liquid form, or how much percentage is semi-solid or how much percentage is liquid. Is it? Am I right, Arshad?
No, sir. Actually, our aim is to keep the metal in liquid form in that riser. How we
Is
ensure that? How we make it possible? It stays in liquid form.
is Let me go to that.
Or sir, what are the conditions that favor the molten material stays in liquid form in riser?
Okay. Okay, so like is the material which is over here. Okay, initially this is the molten material is coming there. Okay, this one liquid material is coming. So whatever the molten material is there, it will only try to lift, okay, because this is coming from the bottom part, okay. So it will coming from the bottom part. So this this solidified material, this molten material which is over here, it will try to become solidified. It will try to become solidified, okay. Then the material which is bottom at that, it's not like this is recently filled the material. It was filled when this material is lifted, that time the new material was filled. So it is basically one layer is formed here, and then it is going to up. So it means that one layer which was filled over here, then there was a second layer, and then there was a third layer, fourth layer, fifth layer, and this is only the filling up. So this is the first layer, this is second layer, this is third layer, this is fourth. And the material which is coming out from the riser, if it will become solid, guys, if it will become completely solid, then this will be filled, this complete mold cavity will be filled. And the material which is we are pouring from the pouring basin, it will, this liquid material try to come back from this side only, but we do not want that, okay. So what we are doing is, if there is a necessity, like, yeah, your one question is valid here, that when you are that what there's a possible, because we want that this liquid material should come out from the riser. So what we are doing is, if there is a necessity that if this molten material which we are pouring, it will become solid in between, only in between the surfaces, then we are creating two surfaces differently. Means if the height of this cylinder is high enough, that the whatever the molten material that we are feeling, then it is then it is complete becomes solidified in between only, in between only. Then it is completely solidified, then definitely whatever the space is there at the top, we cannot fill that material, okay. So for what we have to do, we have to make it like, we have to lift it, this we have to increase this gap from this one to this one. We have to increase this gap. If we are keeping it small h, then we have to increase this small h, what according to this whatever the area that we are not filling. So that will basically through which basically we get to know that, okay, that material is coming out from the riser, and this is complete cavity has been filled, okay. Otherwise this material will back, okay, from the pouring basin only. So that is that's the meaning, like the solid is already formed, and we cannot enter the molding liquid material towards this. There is another possibility is, like as you said that uh, till the riser this material is coming. So it should be in liquid or semi solid only. So there are again two questions, that how much percentage of the liquid and how much percentage of the semi solid. But first I'm answering that it should be in semi solid or the liquid form. So first of all we are changing the height, okay, changing the height. Or still, if we are unable to change the height, or still it is going to be solid in between only, then we have to reduce the space of this mold cavity, and we have to make two different casting, then we will weld it, okay. Like for an example, आपका फर्स्ट टाइम में टोटल हाइट जो है इसकी जस्ट डबल है, ठीक है. इफ वी हैव टू मेक दिस डबल हाइट कास्टिंग, so if this material we are which is filling from here, it will become solid up to here. So first of all we will create this casting, then another same height we will create the same dimension, all this thing we will create the other casting, and then we will keep one over each other, and then we will weld it. This is the process. Or what we can do is, by the way we are not doing this one, but still there is a possibility, then we can add the heating elements. Heating elements means like different types of the heating elements are there. So they will basically maintain a constant temperature of like 300, 400, 500 degrees centigrade. So they that we can attach over here along with this molding sand. Okay, so that is maintaining at 400 300 400 degrees centigrade. So they whatever the material at the boundaries, because from the boundaries only this material is trying to become solid, semi solid, okay. So the we are keeping this heating element at the boundaries, so this material should not easily become solidified, semi, it will not become easily very semi solid, till it will fill up to this specific height that we are keeping. uh, Arshad, I'm able to answer your question.
Yes, sir. Thank you, sir.
Okay. Okay. So, uh, Okay, guys, we are keeping today up to here only. In the next class, we will discuss these rest of the four lances. But still, any of the students has any doubt, you can ask me. Okay, till that, I'm just taking your attendance.